Okay, so welcome to this next video. In the previous set of videos, we worked with the 0-1 knapsack dynamic programming pattern with a top-down approach. In this video, we switch gears to the bottom-up approach, and this is exactly what you're going to do. So this is the same questions. Imagine we still have the weights 1, 3, 5, and the profits we expect from those weights. It's still 2, 4, 7, 10. And the maximum weight you want to maximize for is 8. So in the bottom-up approach, you're going to work on a grid. So this is how we're going to store the full memory there. And I'll just show you how you go about this particular grid so that you get the code logic. The columns are going to denote the maximum weight. And we're going to start counting the maximum weight from 0, all the way till this number of the maximum weight. So I'll call this n. So let me just call that n, for example. And then the weights, right, or the items we have, I'm going to call them m. Actually, let me just give this a different sort of denotation. Let me say that the maximum weight in our knapsack is going to be m, and the number of items in our knapsack is going to be n. Let's just have that all through. So this is going to be an n by m grid, and I'll show you how to go about it. So the first thing we're going to ask ourselves, and this is going to be the core base case for us, is when we have no items, so it means like the weight is 0 and the profit you're going to get from that is also 0. So in this particular instance, we have no items at all. So when you have no items at all, then it's very obvious that our knapsack can only make a maximum profit of 0. There's nothing we can do about it. So that's worth noting all through. And that's how we are going to instantiate this particular knapsack problem. So the first thing is we create an n by m grid where on the x-axis we have the items, and on the y-axis, okay, there's probably no axis here. So on this side, we're going to have the items, and then on this side, we're going to have the weights, and we're just going to instantiate and say that if there's no weights, there's no profit you're going to get. If there's no items, there's no profit you're going to get from that particular knapsack. Okay, so now let's go to the next row and let's ask ourselves, if I have weight 1 and the maximum weight I'm going to get off of this is 1, what is the profit I'm going to get? So definitely, the first thing I'll be looking at is if my maximum weight is 1, I ask myself, does this weight fit in my knapsack or not? So that's going to be a big question for me. Yes, it does. And if it does, this is the only weight available to me, so I'm definitely going to get a profit of 2. So let's just fill this first sort of column with logic before we come up with the pattern there. The second thing is we have a maximum weight of 2, but at the same time, we have a weight of 1. So this weight is actually less than the maximum weight, which means we can include this weight there. So we'll still get a profit of 2. If we come to 3, the same applies. Maximum weight is 3. We have an item, only one item that has weight 1. It can fit in our knapsack, and the profit we'll get from that is 2 as well. And this will be the trend all across as well. So for all these sort of numbers that are above 1, we can easily go ahead and realize that so long as my weight fits, I can get my maximum profit off of it. And that's no problem whatsoever. Okay, so that is the first layer. Now, let's make it slightly trickier by adding a second item. And this item has a weight of 3 and a profit of 4. So how do we go about it? So when you have weight of 1, and here we're looking at our second item, it has a weight of 3. So keep in mind we have 2 items. So weight of 1, and we have these 2 items available in our knapsack. So I have a weight of 1, and I have this first item has a weight of 3. Unfortunately, I can't include that because this weight is higher than the maximum weight in my knapsack. So it means the only weight I can consider here is going to be weight equal to 1. So that item with weight equals to 1, which gave me a profit of 2. So because I can't include this, it means like I can only include one item, and that's going to be a profit of 2. So in simpler terms, it feels like I'm bringing this down. Okay, so we are solid on that. The next one, we're still looking at a maximum weight of 2, and this item has weight 3, so we still can't consider it, so we can only consider this particular item. And when the maximum weight was 2 at this particular item, the profit was 2 as well. So I'm just dropping this number down. So the logic we're starting to get here is if we cannot include this item in our knapsack because it has a greater weight than the maximum weight in my knapsack, then what I'm just doing is I'm only considering the previous row. So I'm just coming to the previous row and dropping down that number down because this was the maximum profit I could make if this was the only weight, and this was the maximum weight. So just keep in mind, so I'm just dropping it down all through. And now let's get to the trickier scenario. What if we have a maximum weight of 3 in our knapsack? Now, the logic is slightly different because now we can include this particular weight. So what do we do in that particular instance? So in this instance, we have two options. It's either we include this weight, so we include this item with weight 3 and profit 4. So that's going to be the first instance. If we include this item of weight 3 and profit 4, what you're going to come up with in the knapsack is going to be 4 plus the remaining weight. What is the maximum we can get from the remaining weight? So if I include this item 3, I get a profit of 4, and then I realize that now my maximum weight has reduced from 3 to 0 because I have to deduct the weight of this item, which means 3 minus 3 weight here, it comes to 0 here. And so now I'm on here and I'm asking myself, what is the maximum profit I could get when my knapsack has a maximum weight of 0 and the only item I have is the previous item. So keep in mind, because I've already included this item, I'm literally checking this number. So the remaining weight in my knapsack, which is 0, and when the only items available is this as well, weight 1 as well. So if I include 3, I'm literally just saying 4 plus I'm taking 3 steps back and going to the row below plus 0. And I hope you understand the logic here. And the logic is that after I include this item, whatever's remaining in my knapsack, which is a maximum weight of 0, and the only items I have available in my knapsack after including this item is going to be this item. So I'll be coming back to maximum weight 0 and the only weight I have available is this item 1. Okay, so that's going to be 4 plus 0, which is going to be 0. The other option that I have here is what if I just ignore this item and I just focus on the previous item. So if I just use the previous items, the maximum profit I was getting is just the previous sort of row response, which was 2. And what I'm trying to do is I'm trying to maximize 4 and 2. And if I maximize 4 and 2, the answer is 4. So it means in this particular scenario, when I have weight 3, all I have to do is I'll make a maximum profit of 4. And this is pretty much if I use weight 3 and I come and there's no more space left in my knapsack versus using weight 1, which just gives me a 2. So that does not make so much sense. Okay, for this one, it didn't make so much sense. I know it's not as clear because when we include this item, we fill the weight in the knapsack. So my question is, what happens here in 4? I think our logic is going to work better here. So we have two instances or two options for us. So the first option is we ignore this row completely and we just use the previous items. So if we ignore this row completely and just use the previous item, which had a weight 1 and profit 2, simply I'm dropping this answer down. So that's my first option. I can either get a 2 as my maximum profit, or because the maximum weight here is greater than the weight of my item, I can include this item. And if I include this item, I get a profit of 4, yes, plus what is the profit I can get without this item when I now have 4 minus 3 left. So now if I include this item, I have weight of 1 left. So you go ahead and realize that I have to take 3 steps back, and here I'm on this particular row, and I've already included this item. So literally what I'm trying to maximize is I have a maximum weight of 1 left, and the only item I can consider now, because I've already considered this, is going to be this. So I'm literally taking 3 steps back, and I'm going to the previous row, and I get that when I had a maximum weight 1 and only 1 item, the profit was 2. So I can easily get 4 plus 2, that's my instance, which is 6. Okay, so my instance there is going to be 6 versus 2, and the maximum here is 6. And I hope you get the logic here. And the logic is, if I decide to include this item, I will take its profit plus the profit I get by going the weight of the item back. So this is going to be 3 steps back and looking at the maximum profit I made in the previous row. So that's the instance, because yeah, it's going to be the profit I get from this plus the profit I get from maximum weight 1 and only 1 item in my knapsack. And the same logic is going to apply here. So my first instance is, if I don't include that item, I have a 2 as an option, or alternatively, I can include this item, so I get a profit of 4 plus, let's take 3 steps back, 1, 2, 3. So we take 3 steps back, and then we ask ourselves, what was the profit here as well? So I come to the previous row as well. So just note, this is the number I'm looking at, plus 4 versus this, right? So it's either I bring this down or I try maximize at a maximum weight of 2 and only this item, what is going to be my profit. So that's also going to be 2. That's still going to be like 2 versus 6, because it's 4 plus 2 there. And so we also get the maximum here is going to be 6. Okay, so let's go to the next row as well. And the next row, we still keep up the same momentum. We check what if we don't include this item. So we just go to the previous row. So I'm still gauging that particular 2. And then what if I include this item? So I get a profit of 4 plus, let's go 3 steps back, right? And then previous row, and we realize here we also had a maximum profit of 2. So it's still 2 versus 6, and there the maximum is 6. And you'll realize, because these are the only 2 items, this will be the same sort of scenario across all these columns anyway. So the same logic applies. Now let's come to this next one and make it slightly tricky as well. So let's see what happens here. So here our item has weight 5. So when our item has weight 5 and the maximum weight in my knapsack is 1, definitely we can't include this item. So it means we're just dropping down the response from the previous row as well. So it means this is going to be 2. Here our weight is still less than, the maximum weight is still less than the weight of the item. So we still include 2. So we are pretty much dropping down here. So here we drop down the 4. So when we can't include this item, it simply means we take whatever was the optimal value when we didn't include that item, which is going to be the response in the previous row. So we're literally looking at the number above it at any given instance, up until we can fit this item in the knapsack. So this is going to be 2, we drop 2 down, we drop 2 down, we drop 4 down. 4 is still less than the weight, so we drop 6 down as well. So up to there, we're doing okay. So now we get to 5, and now the logic is slightly different, because 1, we can either fail to include that item and get a maximum profit of 6, or we can include that item and get a profit of 7 plus. And now let's remember what we do. If we include this item and we get a profit of 7, it means we have to reduce the weight available in our knapsack by 5, right? So we have to take 5 steps back. So 1, 2, 3, 4, 5. So we take 5 steps back. And after taking 5 steps back, we look at what was the maximum weight just above that as well. Because this is going to be when we only had these 2 items and the maximum weight was 0, we still got a 0. So that's going to be 6 versus 7, and the optimal value is going to be 7. So that's an example there. We go to the next one, and we still use the same logic. So once again, it's either I don't include this item at all, so I drop the number from the previous row, or I include that item, which has a profit of 7, and I take 5 steps back. So 1, 2, 3, 4, 5. And now I ask myself, what is the number above it, which is going to be what is the maximum profit I can get if I only had these 2 items and a maximum weight of 1, which is 2, right? And the reason we have a maximum weight of 1 is because 6 minus 5, which is the weight taken by this item, leaves us with only a weight of 1. And because this item is gone, we're only left with these 2 items to consider. So just note that. But the logic is, I'm either dropping this number down or I am including the profit of my item plus we take the weight of the item steps back and we look at the previous row. So this will be 5 steps back and the previous row. So this 2 plus the profit of that item is going to give us a 9. And if I compare a 9 and the 6, the maximum value is going to be 9. So I hope we get the logic now. Let's come to 7 as well. So I'm dropping the 6, or I'm taking 7 plus, and I take 5 steps back. 1, 2, 3, 4, 5. I hope I'm doing it right. So it's going to be 1, 2, 3, 4, 5. And I come to the previous row. So that's still 2. So 2 plus 7 is 9, versus 6. So the maximum here is also going to be 9. Then let's finalize with the previous one, with the final one as well. So here we're still dropping a 6 from the previous row, and then we are trying to gauge the 7. So if we include the item, and then you take 5 steps back, 1, 2, 3, 4, 5, and then the previous row we got like the value was 4. So 7 plus 4 is 11, versus 6. So we go ahead and say 11 is greater than 6. So we are maximizing it at 11. So that's how we fill that particular row. Now let's fill the final row just to test whether we have the logic. You can pause the video now and ask yourself whether the numbers you get will be similar to the numbers I get at the end of the day. So just try to do this on your front as well, and let's see what you get. Okay, I'm guessing you've already tried. So let me go ahead and do this on my front. So once again, when this weight, when the maximum weight in my knapsack is less than the weight of my item, I don't include this item at all. So it means I just drop the number in the previous row. So that's going to be 2. It's going to be 2. That's going to be 4. That's going to be 6. That's going to be 7. That's going to be 9. So I'm just dropping the number from the row before up until we get here. And now here, I have to compare the number from the row before versus the value I would get by including this weight. So I'm either comparing the number from the row before versus I get a profit of 10 plus I take now the steps I'm taking back is 7. So 1, 2, 3, 4, 5, 6, 7. And then I got the previous row and I get 0. So it's either 10 plus 0 versus 9. And so the maximum there is going to be 10. Now let's finalize this final thing as well. So this is also means like I compare the value of the previous row, which is 11, and I compare 11 with 10 plus, let's see what you're adding it with. So we take 7 steps back. 1, 2, 3, 4, 5, 6, 7. And I got the previous row, which is 2. So 2 plus 10 is 12 versus 11. So we get our maximum here is going to be 12. And so whatever I'm going to return as the maximum profit I can get from this with the bottom-up approach is going to be the value of the final row there, which is going to be 12. Now, that's going to be the logic, and the logic is and let me just summarize the logic. So we have 2 scenarios of the logic here. So the first thing is I gradually add a weight into my knapsack. So I start by having no weights or no items, and then I include one item, and then now I include another item, and when I'm including another item, I just compare what was the value I got from the previous item for all numbers. So what we'll start realizing is the core logic here is if the maximum weight in my knapsack is less than the weight of my item, like here, so for example, when we are here, this value is pretty much like we drop down the value from the previous row. So we bring this value down. That's when the weight of my item is greater than the weight available in my knapsack. But in the instance where it is not, we can go ahead and say that we're trying to maximize 2 values. It's either we are dropping down this number from the previous row, or we are taking the profit from this item, and then we go ahead and take 7 steps back, or the actual way is the weight, so we reduce the weight in our knapsack. So if we include this item and include a profit of 10, it means like the remaining weight in my knapsack is going to be this maximum weight minus the weight of the item, which is 7. So I have to take 7 steps back. So 1, 2, 3, 4, 5, 6, 7, right? So I'm taking 7 steps back, and then I'm going to the previous row because I'm just asking myself, the weight remaining in my knapsack is 1, and the items I can consider are these items. So literally I'm looking at the maximum of that grid, which was 2. So 2 plus 10 gives me 12, and I compare it with the previous row response, which was 11, which simply means what was the maximum I could just get from these 5 items if I didn't include my final item as well. And that's the logic. So it's always going to be a 2-pronged approach. So it's a 2-pronged approach, just like the top-down approach. It's just that here we are working with a grid. And then the final intuition of our grid is we don't have to save the entire grid. If you've gone ahead and realized we only need the previous row to save or to solve for the current row. So at any given instance, instead of saving this n by m matrix, if you remember what you're talking about here, instead of saving this n by m matrix, we only need to save like the previous row. So we only need to save m responses here. So it's still linear. So we can reduce the space complexity we have by only saving a particular row and calculating the next one, because we wouldn't need answers from the previous row as well. We only need one row to make that particular